Hi everyone. The question is minimum right shift to sort the array. This is a easy level problem, and in this problem you are given an array. Okay, so basically you are given an array. Let's check this first example. This is 3, 4, 5, and 1, and this is 2. In this problem, you are given an array, and you can right shift the elements. That means in this case, if you right shift once the element, then the array will look like 3 will come to first position, then 4, now it is 5, now it is 1, and 2 come to the last element come to first position. So if you do right shift one time, then the element would look like this. See, you can see in this example. So basically you have to say that how many number of operation will required. I mean, how many time you should perform this right shift operation, so that the array will ordered in sorted order. So basically this is the problem, and you have to find the minimum number of right shift. And if you observe this problem, that the total, I mean, at max, what is the what is the maximum number of right shift? So the maximum number of right shift will be if all the element are in decreasing order, right? So see, in this case I have to right shift 1, then 1 will come to this place, 1, 3, 2, and then I have to right shift once. Okay, so in this case, if we just right shift 1, then it will come to 3, then this will become 2, 3. Okay, so yeah, like this will not possible, I guess. 3, 4, 5, 2, 1 here, 1, no, I mean, yeah. 1, 2, 3, 2 will come to this place, 1 will come to this place. I mean, in this case it is not possible. This side is okay, in this side it is okay. In this case 4 will move to this place, 1 will move to, okay, so in this case it is not possible. I mean, uh, using this operation you cannot sort this array. I mean, the array 3, 2, 1, yeah, like this array. So see, if you sort, I mean, if you perform right shift operation once, then 1 will come to first, then it will look like 1, 3, 2. And if you perform again right shift operation, it will look like 2. Oh, I mean 2, 1, sorry. Okay, sorry, so like 3. Initially we are given 3, 2, 1, and if you perform the right shift operation, it becomes 1, and then 3, then 2. And if you perform right shift operation, then it will look like 2, 1, 3, right? And which 2 will come to this place. Okay, and if you perform again right shift operation, it will look like 3, 2, 1. See, after performing 1, 2, 3, 3 operation, you got your initial array. So at any point, if the array becomes short, I mean array, yeah, like if at any point array becomes short, you just have to return I mean, that many number of steps. And here the maximum number can be 3. I mean you can see from this example that after 3 operation we got our uh, initial array. So similar, then if we perform again the operation, then we'll get this position. And similarly, if we perform again this operation, then we got this I mean this array. So the total maximum number of left shift operation can be n. I mean less than n, obviously this is n less than n if the answer is exist. In this case the answer does not exist, because you cannot sort this array using this operation. Because you can see that after one operation we got this array, and this is not the sorted, and we got second operation, we got this array, and this is not in sorted similarly. And after that it will repeat the above procedure in this 1, 3, 2, then 2, 1, 3, then 3, 2, 1, and similarly it will repeat. And you will not able to, I mean, you will not able to arrange the element in sorted order using the given operation. So my main point is to tell you that what is the maximum number of operation that you need to sort the array. So here the maximum number of operation is n minus 1 or something that. And if you see the constant, here constant is 100. I mean, you can perform the n square operation. So I'm like I have done that only, like I just yeah, like I have done in this way. So I just created temporary array and I mean, yeah, like temporary array and then sort the temporary array. Okay, so I'm checking like here the number of operation maximum. I mean, I have taken like n plus 1, but actually it is n or less than n. Okay, obviously it is less than n. So for like for I mean for safety you can take n plus 1, it is okay. And if I see like at any point if norms equal to temp, I mean temp is my sorted array. So at any point if this equal to then just break, and whatever the number of operation you just return that, this one. And if this is not equal to this, then just do this, I mean cnt plus plus, and just I mean just increment every value, like just right shift left right, yeah, like just right shift one position. This is na 3, sorry 3 to 1. Then after this is norms array, and after that it will look like 1 3 2. This will norms array, and from I mean, yeah, like from this array to this array. So I just swap the element, I mean just increment here the value equal to norms of I, change the norms of I value to previous value, and store the in I mean the current value in val. I mean just yeah, like from I just did here, I mean how we come from this person. So yeah, like this is the, and if cnt value equal to I mean greater than equal to n plus 1, I mean we are perform n plus 1 operation and still we are not able to uh, find the sorted array. So in that case just have to return minus 1, and like they have mentioned here, if you if it is impossible to sort the array, then you just have to return minus 1. And if it is I mean if you are able to if you are able to sort the array, then return the minimum number of operations. So yeah, like this is a simple problem. I mean just brute force method, because the constant is too low, and if the constant is order of n, then we just have to think something about it. I mean, yeah, like we can solve this problem even in order of n time complexity. I mean just observe some, yeah, like because the constant is too low, so then and that's why I didn't think much, and I just implemented this thing. But we can solve this problem in, I mean, linear time. Like just observe that the given array, and you will find some pattern. I mean, yeah, like that's the first problem. The constant make problem very easy. Otherwise I think if the constant is n, I think they will ask this problem in, I mean, yeah, like they uh, mm, yeah, like if the constant is order of n time, they, I think they might ask this problem in medium level problem. But yeah, like so in the second problem, what is given that uh, second problem, basically you are given an array in non-decreasing order, sorted array. I mean non-decreasing order. Non-decreasing order means increasing equal. Okay, so if you take the example of this one, 1349, the arrays, the elements are arranged in increasing order or equal. I mean increasing equal, 1 1 or 1 2, similar like that, in non-decreasing order. Okay, so this is like 1 3, this is 4 and 9. I mean you can solve this problem in, like there are 2 or 3 different methods to solve this problem. The best method is to, I mean using two pointer approach, and but I like I have solved it using some other method. But like yeah, like uh, I'll tell you about the method. Okay, so um, let's take a good example. These are 1 2, this is 2, this is 4 5 5 and 6. Okay, so now what is the question, that you just have to select two indices and such that norms of I is less than norms of j, and I is less than j, and norms of I is less than norms of j. And after selecting those two indices, just remove those two indices from the array, and you just have to tell that what is the minimum size of the array. I mean what is the maximum number of element that you can remove. so that it will minimize our size of the array. Okay, so this is the problem. And also the array elements are sorted in non-decreasing order. Okay, and in this problem in this problem first of all, observe one thing that uh, first of all I'll discuss the two pointer approach. Okay, so in two pointer approach, what you can do is like, what you can do, I mean, just take a pointer from this position, this is I, and just take another pointer from the mid position, I guess, like, this is the mid position, I guess, yeah. Because see, why mid position, I mean, in even case you just like take point, like you just take pointer in mid position, and like if odd case then just mid minus 1. Okay, so why even, just think little, because every time I am deleting two element, so if I like the element should be paired in like what, this person element, this person element, this person element, this person. And like why you are not, like you can say that why, like why we are not taking adjacent element, because see in this case what, 2 and 2, 2 and like 2 is not less than 2, so that's why we cannot, I mean, we cannot erase this, two element. But if you take like 2 and 5, so in this case you can erase, like 2 is less than 5. So because we are taking like this is starting person and this is mid person, that means it will maximize the difference between two element. The elements are sorted in non-decreasing order, and if we take two element like this, then it will maximize the difference between two element, and it will increase the chance of deleting two number, and that is our motive. So to delete two number. Okay, and that's the reason. And why, like why starting point and midpoint, because every time we are deleting two element, and obviously, like if we start from this position element, and when we reach this position, then from this position, we, let's suppose we are able to relate, like let's suppose we are able to find all the element less than this, like this element, while traversing this side, and j will travel this side, and if this is less than the, then just erase this one, and just do here, like if this is less than, I mean, yeah, like if this is less than what, like if this is less than this element, then just erase these two element, and then increase your eyes. So similar way you can do that. And yeah, like when you delete two number, then just mark them as visited. I mean, you can replace that element with -1 or something like that, so that while counting the number of remaining element, it will helpful. I mean, if this like if the position element is not visited, then just increase your count value and return the at that time you return the minimum length of the num sub array. So yeah, like this is the one method. And another method, the method that I did, like during the contest is, I just find the frequency of the all the element. Okay, and here the frequency of one is 1, and the frequency of 2 is here 2, and frequency of 4 is 1, and frequency of 5 is 2, like similar way I just find the frequency of element. Let's write the frequency of element. Okay, frequency of 1 is 2, and frequency of 2 is here 2. Okay, and here frequency of 4 is 1, and frequency of 5 is 2, and frequency of 6 is 1. Okay, so I just find the frequency of element, and I put all the values into a multi set. Okay, basically you can say the priority queue, I mean max heap. Okay, max heap. And every time I just take out the I mean like I just take out the top two element and decrement their value, and then again if the value is greater than 1, and then I just put them into the max heap. And like similarly I just did. And why, like you can say that, like why, I mean, what I am trying to like what I was trying to do, um, I just want to decrease the elements having maximum frequency. Okay, and yeah, like that was like that was I mean, that's the thing that I was doing. uh, Yeah, like the intuition behind this is like it suddenly click. I mean, I have solved this problem, but yeah, like it's not like I have solved, but why, like why we are doing like why I was doing that. Okay, so I mean, if you uh, mm, I mean, if you take one example, see here, I just erased 2 and 5. At first, what is the maximum frequency of element? Maximum frequency of element 2 and 5, so I can able to erase 2 and 5. And then all the frequency becomes 1. Then I can take any two element, I mean any two top element, and then decrease their frequency. Similar way, if this is gone, then this will found. I mean, the reason is that why we are like take the maximum two element. Okay, so the thing is that why maximum? Because maximum element means like we are just trying to see the frequency of one element is 3. I mean, the element, that element occur in the that element occurred in the array 3 times, and another like frequency of another element is like, let's suppose 3. So and that element occurred in array 3 times. So if I just take those two element and reduce with the element, so yeah, like that was the thing. I mean, you can say that like we are just greedily reduce. You can say that like, bro, we can just like not using that max if, and we can just greedily reduce the I mean, we can reduce greedily reduce the element frequency. We can do that, but I don't think we that will work. Like there will arise a case where that approach will fail. What is the case? I mean, I right now I'm not able to recall that test case. I mean, yeah, like right now I'm not able to recall that test case. But yeah, like if you take some example and try to do the try to solve that in gridly, then you will, I mean, you'll find a test case where your approach will not work. So basically this is the thing, that frequency using find the frequency using map, and then I just put the everything else in multi-set. So you can use priority queue, because yeah, like I used here multi-set, and similarly every time I just take out two element and reduce their frequency. And yeah, like this is the second problem. Okay, yeah, like, and let's just discuss the this fourth one. I mean, I was a little bit slow in, I mean, today's contest. I don't know why, like I'm very slow. Yeah, like I was very slow. Okay, so we'll discuss the last problem in next video.